We've already covered lists a little, and we've been making good use of them. We know how to create lists using the literal syntax, add to them using the append method, and get at and modify their contents using the square brackets indexing. Now let's take a deeper look. Let's start by making a list containing the words show how to index into sequences. We'll do this by calling the split method on a string. We're already familiar with how 0 and positive integers index the list from the front using a zero-based index. Here we extract the fifth element by using the index 4. One very convenient feature of lists and other Python sequences, for this applies to tuples too, is the ability to index from the end rather than from the beginning. This is achieved by supplying negative indexes. For example, we can access the fifth element from the end by supplying the index -5. The last element of the sequence is at index -1. Negative indexing is much more elegant than the clunky alternative of computing the forward index by subtracting the backward index from the length of the sequence. Note that indexing with -0 is the same as indexing with 0, returning the first element in the list. Because there is no distinction between 0 and -0, negative indexing is essentially 1-based rather than 0-based. This is good to keep in mind if you are calculating indexes with even moderately complex logic. Off-by-1 errors can creep into negative indexing fairly easily. Slicing is a form of extended indexing which allows us to refer to portions of a list. To use it, we pass the start and stop indices of a half-open range separated by a colon as the square brackets index argument. Here we slice 3 words from the list by passing the start index 1 and the stop index 4. This facility can be combined with negative indexing. For example, to take all the elements except the first and last, slice between 1 and -1. Both the start and stop indices are optional. To slice all elements from the third to the end of the list, supply only 3 colon as the argument to the index operator. And to slice all elements from the beginning of the list up to, but not including the third, supply :3 as the argument to the index operator. Notice that these two lists together form the whole list, demonstrating the convenience of the half-open range convention. Since both start and stop indices are optional, it's entirely possible to omit both and retrieve all of the elements, and indeed this last example is an important idiom for copying a list. This new list has a distinct identity, but an equivalent value. It's important to understand that although we have a new list object which can be independently modified, the elements within it are references to the same objects referred to by the original list. In the event that these objects are both mutable and modified, as opposed to replaced, the change will be seen in both lists. We teach this full slice list copying idiom because you are likely to see it in the wild, and it's not immediately obvious what it does. You should be aware that there are other more readable ways of copying a list, such as the copy method, or even a simple call to the list constructor passing the list to be copied. Largely, it's a matter of taste. Our preference is for the third form using the list constructor, since it has the advantage of working with any iterable series as the source, and not just lists. You must be aware, however, that all of these techniques perform a shallow copy. That is, they create a new list containing the same object references as the source list, but don't copy the referred to objects.